Imagine a machine that can lift an object weighing hundreds of tons and send it soaring through the sky. This isn't a tale from a science fiction novel, but a marvel of modern engineering. It's the incredible power and complexity of jet engines that we're talking about. Jet engines, the heart of every aircraft, have completely revolutionized the way we travel. They've shrunk our world, enabling us to hop from one continent to another in a matter of hours. But what makes these engines so powerful? It's a symphony of precision engineering, intricate design, and the raw force of physics. In the realm of aviation, jet engines are the unsung heroes. They're the workhorses that tirelessly propel enormous metal birds across vast oceans and continents, making our world smaller and more connected than ever before. Such a machine exists, and it's known as the jet engine. At its core, a jet engine follows a simple principle: suck, squeeze, bang, and blow. To break this down, let's start with suck. This refers to the intake of air. A large fan at the front of the engine pulls in a hefty amount of air. Next up is squeeze. This air is then compressed by a series of fans, reducing its volume and increasing its pressure. Imagine squeezing a balloon filled with air. That's essentially what's happening here. This leads us to bang. The compressed air is mixed with fuel in a combustion chamber and ignited. This causes an explosion of sorts, releasing a huge amount of energy. Finally, we have blow. The hot gases from the explosion are thrust out of the back of the engine, propelling the aircraft forward. Newton's third law at work. For every action, there's an equal and opposite reaction. This series of steps is constantly repeated, creating a continuous cycle of power. A jet engine may look complex, but it's made up of a few key components. Let's dive right into these principal parts, starting with the intake. You can think of the intake as the jet engine's mouth. It's the very front of the engine, and its job is to gulp down a whole lot of air. This air is then forced into the next component, the compressor. The compressor, true to its name, compresses the air. It's a series of spinning blades, each one progressively smaller than the last. And as the air moves through, it gets squashed down, increasing its pressure. You can imagine the compressor as a very forceful straw, sucking up the air and squeezing it tight. Next up in line is the combustion chamber. Here's where things get hot, literally. Fuel is added to the high-pressure air and ignited. This creates a powerful explosion of hot gas. It's like a controlled mini firestorm happening right inside the engine. This explosion releases a huge amount of energy, which powers the next component, the turbine. The turbine is a set of blades arranged in a circular pattern, similar to the compressor, but it's doing the opposite job. It's not compressing, it's expanding. The force of the hot gas coming from the combustion chamber spins the turbine around at high speed. This spinning motion is used to power the compressor at the front of the engine. It's a clever bit of engineering that ensures the engine is self-sustaining once it's started. Finally, we have the exhaust. This is the jet engine's tail end, where the hot gas, now cooled and lower in pressure, is expelled. This expulsion creates a forceful thrust in the opposite direction, propelling the jet forward. It's Newton's third law in action. Every action has an equal and opposite reaction. So there you have it, the key components of a jet engine: the intake, compressor, combustion chamber, turbine, and exhaust. Each of these components plays a crucial role in the functioning of the jet engine. But how exactly does a jet engine create the power to lift an airplane off the ground? Well, it's all about harnessing the laws of physics, specifically Newton's third law of motion. This law states that for every action, there's an equal and opposite reaction. In the case of a jet engine, the action is the expulsion or thrusting of air and fuel out of the back of the engine. This powerful blast of air creates a force that is equal and opposite to the direction of the expelled air. This force, or thrust, propels the airplane forward. The more air the engine can take in and expel, the more thrust it can create. This is why jet engines are so large and why they generate such a tremendous amount of power. Remember, it's not just about the mechanics, but the scientific principles that underpin them. The science behind jet engines is a perfect example of physics in action. Jet engines are truly remarkable pieces of engineering. They stand as a testament to human ingenuity, harnessing the laws of physics to defy gravity and traverse the skies. Let's take a moment to revisit the magic of these mechanical marvels. Jet engines operate on the principle of action and reaction, drawing in air at the front, compressing it, mixing it with fuel, igniting the mixture, and finally ejecting it at high speed out the back. This process involves a symphony of components, each playing a vital role: the fan, the compressor, the combustion chamber, and the turbine. All work in harmony to produce the thrust needed to propel an aircraft. The science behind these powerhouses is both fascinating and complex, a dance of thermodynamics, fluid dynamics, and mechanical engineering. It's a testament to the marvels of human innovation. Through a combination of simple principles and complex engineering, jet engines power our journeys through the skies.